So let's go ahead and go over this. So really quick, in order to graph this, the first thing that you're going to do is ignore this little inequality. Okay, so that's like that little alligator symbol. You know, this is saying y is bigger than x squared minus 4x plus 3. Okay, so wherever that alligator mouth is actually facing, that's going to be the bigger number. So y is greater than. Over here, this is y is less than or equal to this function. Okay, so that's actually how you read it. Now, in order to graph it, you're going to take the function and just graph it like you normally would, right? So we're going to take x squared minus 4x plus 3. We're going to put that into our Desmos. If it'll ever load. Yeah. Okay. So once we get here, what we're going to do is we're going to type in that function. So x squared minus 4x plus 3. That's what it said. Yep. Okay. So we've got this right here, which is coincidentally exactly what's already graphed right here. Now, since it doesn't have a line underneath, there's no line right here. Okay. What we're going to do is we're actually going to make this line right here dashed. Okay. So instead of a solid line, this is going to mean that we're dashed line. Okay. And then what you want to do is you want to shade, because this could have multiple answers, right? Like 3 is bigger than 2. 4 is also bigger than 2, right? So 3 is bigger than 2. 4 is also bigger than 2. So there's multiple. So let's take a point either on the inside of this or the outside. I always like to plug in 0, 0 because it's really easy, right? And I'm going to check and see if the point 0, 0 works for this statement. If it's true, I'm going to shade towards 0, 0. If it's false, I'm going to shade away from 0, 0. So I'm going to take the point 0 and plug it in for my x's, and then 0 and plug it in for my y's. So when I simplify the right-hand side, I'm going to get 3. Is 0 bigger than 3? No. So I'm going to shade away from 0, 0. Okay? So again, I took a point and just plugged it in to see if that statement's going to be true. So looking at the next one, I would take this equation, I would plug it into my graphing calculator. It's going to produce this graph, okay? So now, since there's a line underneath, we're going to make this a solid line, right? So it's not going to be dashed, right? And now we've got to figure out if we need to shade towards or away from a point. So again, I'm going to pick the point 0, 0, and I'm going to plug it into my equation. So 0 is less than or equal to 3 times 0 to the second power plus 4 times 0 minus 4. So if I simplify that right-hand side, I'm going to get negative 4. Is 0 less than negative 4? No. So I'm going to shade away from 0, 0. So I'm going to shade on the outside. Okay? The reason I'm going to shade on the outside is because if I take any point on the outside, let's say I picked 2, 0, this point right here, and I plug that into this equation, it's going to make that statement true. So if I plugged in 2, 0, and I simplified this right-hand side is going to be bigger than 0. So that's why I'm going to shade away from 0, 0. You can pick any point. You're just trying to see what points will make that statement true. All right, so if I were to actually graph this, I would come in here and I would say x squared minus 5x, x squared minus 5x minus 14. Okay, and I see that this is my graph, right? Okay. and then it's less than or equal to 0. Okay, so what I'm going to do here is I'm going to go ahead and I'm going to graph it, which this is what my graph is going to look like. Take a screenshot and pull it over here. Right? Okay. So then what's going to happen is I'm going to try to figure out, am I going to shade towards 0, 0 or away from 0, 0? Okay. So if I take the point 0, 0 and I plug it in, 0 squared minus 5 times 0 minus 14 is less than or equal to 0. And I simplify this, is that a true statement? Yes. So then that means that I'm going to shade towards 0, 0. So I'm going to shade all the inside of this. Okay? Now I'm going to take this equation and plug it in. 2x squared minus 7x plus 3. 2x squared minus 7x plus 3. Okay? And again, I'm going to take 0, 0, which is on the outside this time, and plug it in. So I'm going to get 2 times 0 squared minus 7 times 0 plus 3. And that was less than 0. Okay, so when I simplify this, I would get 3 is less than 0. Is that a true statement? No. So I'm going to shade away from 0, 0. Okay? Again, looking at my inequality, remember this would have been dotted, right? Or dashed, if you will. Now there is, I think, a feature in Desmos where you can actually do this, and it graphs it for you. And it even has the dash part. So you really don't have to do this a whole lot by hand. Okay? So that is an option. Okay? An object is launched at 19.6 meters per second from a 58.8 meter tall platform. All right, so first of all, we've got this platform. It's 58 meters, 58.8 meters, and we're launching it, right? And it's going to like fall to the ground, right? Okay? And so we're given this equation. When does the object hit the ground? Okay, so I can take this and I'm going to plug it into my calculator. So I've got negative 4.9 x squared plus, I think it was 16x plus 58.8. 19.6. Okay? Now, of course, this is a real world scenario. We always want to start here. Like, we don't want to have anything that was negative on the left-hand side or the right, or on the bottom, right? So we can actually zoom in and kind of make this realistic. Okay, notice how it crosses the y-axis at 58.8. And then where does it actually cross? The x-axis. It crosses at 6. So after 6 seconds, it would hit the ground. Because remember, the x-axis is the ground, right? So when did the object hit the ground? At 6 seconds. Okay? Alright, so on number 6, it says an object is launched directly upward at 64 feet per second from a platform 80 feet high. The equation is that. At how many seconds will the object have a height of 90 feet? Okay, so you're going to take this equation, you're going to plug it into your calculator. Okay. And then it asks, when would it hit 90 feet? Okay, so we see 90 is going to fall right in here, right? So 90 is going to fall right in here around 3.8-ish, 3.84, okay? And it also hits at 90 at 0.165. All right, so when x is equal to 0.165, and then when x is equal to 3.84. So why are there two answers? Because it is a quadratic. So it goes up and then comes back down. All right, so an object is launched from the ground level directly upward at a rate of 48 meters per second. The equation is this, and at what values of x is the object at or above a height of 32 meters? Okay, so we're going to take this equation, and we're going to plug it in here. Okay, we're going to look at the graph. And then the question actually asks, when is it at or above a height of 32 meters? So we're going to look at our y values. And whenever it hits above 32, so it hits at 1, and then it also hits at 2. So in between 1 and 2. How long is the object at or above this height? For 1 second total. Because we would take 2 seconds and then subtract 1 second. All right, so we know that the area of a rectangle is length times width. We know that the area is 560. We know that the length is 3 more than twice the width. So 3 more than twice the width times our width. And then now we need to find the width and the length. So I'm going to distribute this out. And now it's a quadratic. So we're going to move everything to one side. And so this is going to be 2w squared plus 3w minus 560. I'm going to take it and plug it into my calculator. Okay. And then I'm going to look for where it crosses the x-axis. Well, it crosses at 16, and then it crosses at negative 17.5. Can we have a negative width? No. So our w is going to be at 16. So w is 16. And then in order to figure out what our length is, remember it's 3 more than twice the width. So 3 plus 16 times 2. So 3 plus 32, which is going to give us 35. And if we want to check this, then we take 16 times 35. And that gives us 560, which is our area. We did it correctly.